Hello students, and welcome to this module of Home Tutors. In this module we will be looking at trigonometry, and in this module we will be looking at the following sections. We will look at Pythagoras theorem. We will also discuss trigonometrical ratios, the sine rule, the cosine rule, and special angles. This module promises to be quite intensive but also very interesting. Trigonometry seems to be a very pivotal topic in mathematics. So it is very important for you to pay rapt attention and make sure that whenever necessary, you don't refuse to replay any section you don't properly understand until you understand them properly. Now come along with me as we go into the first section, Pythagoras theorem. Basic definitions. In a right-angled triangle as shown below, the sides A, B, and C are related by the equation C squared equals to A squared plus B squared. That is, the square of the hypotenuse is equal to the sum of the squares of the other two sides. And this is what is known as Pythagoras theorem. Now, what is a right angle triangle? In previous modules, we have looked at certain properties of triangles, and we said that the sum of angles in a triangle is 180 degrees. In a triangle in which one of the angle equals to 90 degrees, such triangle is called a right-angled triangle. And in the triangle you are seeing on the screen, this angle is a right-angled triangle, angle 90. So, once you have a triangle that satisfies the condition of being a right-angle triangle, the Pythagoras theorem holds and states that the square of the hypotenuse is equal to the sum of the squares of the other two sides. For example, in the right-angled triangle below, find the lengths of the sides x and y. Now, there are two triangles embedded in a way in each other in the triangle you have on the screen. We have a big triangle ABC, which is a right angle triangle. We also have another triangle ABM, which is also a right angle triangle. And also we have a third triangle AMC, but which is not a right angle triangle. Now, how do we proceed to solve for y and x? Now, considering triangle ABM, and by applying Pythagoras principle, you will have y squared plus 5 squared must be equal to 12 squared. Do you remember? The square of the hypotenuse is equal to the sum of the squares of the other two sides. So from triangle ABM, you have y squared plus 5 squared equals to 12 squared. From that, you can have y squared is equal to 144 minus 25. That is when you collect like terms. That gives you 119. From where you can calculate y to be equal to square root of 119. and that gives you 10.9 centimeters. Now that you have calculated y, it's easier to calculate x, because by considering the triangle ABC, you can now say y squared plus 5 plus 11, because the length BC is 5 plus 11, which is 16. So you have y squared plus 16 squared will be equal to x squared. Remember, the square of the hypotenuse is equal to the sum of the squares of the remaining two sides. So from triangle ABC, you have this, from where you can calculate x squared to be equal to 119 plus 256, which gives you 375, and then x will be equal to square root of 375, which gives you 19.4 centimeters. Example 2. In the right-angled triangle ACM below, ACM, find the length of the side x. Now, in triangle ACM, let's assume that the hypotenuse AC has a length y centimeters. Hence, according to Pythagoras' theorem, y squared must be equal to x squared plus 4 squared. That is, y squared equals to s squared plus 4 squared. And that gives x squared equals y squared minus 16. But then, this is a single equation with two unknowns. We can't just solve this equation beyond this point. So, what else can we do? In the diagram on the screen, you find out that there is another system of right-angled triangle, which is the right-angled triangle ABC. Considering the right-angled triangle ABC and applying Pythagoras, you will have 12 squared plus y squared must be equal to 13 squared. From where you obtain y squared will be equal to 13 squared minus 12 squared. That is, y squared equals to 169 minus 144. That gives us 25. Now, instead of trying to calculate y, you don't need to calculate y, because in the earlier equation you are trying to solve, for x squared equals to y squared minus 16. And from triangle ABC, you have been able to obtain that y squared equals to 25. All you just need to do is to go back to this equation and replace y squared with 25. And that is what we are doing here exactly. So, x squared equals to y squared minus 16. But y squared have been calculated to be equal to 25. Therefore, x squared equals to 25 minus 16, which is equal to 9. And that gives us x equals to square root of 9, which will give us 3. I do hope you understand that. Well, if you had wanted to, you could go ahead to solve y completely at this point to say y equals to 5. No problem. In that case, you will have y equals to 5. And then you will go back to your equation and say x squared equals to y squared minus 16. And then, since you already know that your y is 5, you will be able to come back to the fact that y squared will be equal to 25. But then, to make it shorter, what you needed in the equation is y squared. So once you get to this point and you have an expression for y squared, you could just replace y squared in this equation with the value from this equation, and then proceed to just calculate your value of x. Example 3. In the right-angled triangle ACM, find the length of the side x. This ACM is a right-angled triangle. This is angle 90. So we are told to find the value of x. Now, from the right-angled triangle ACM, let AC equals to y centimeters, that is the hypotenuse. Now, according to Pythagoras, this expression will hold, that y squared must be equal to x squared plus 12 squared, because Pythagoras theorem says in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. That is, y squared equals to x squared plus 12 squared. This is it. But then, what we are trying to calculate is x. So, if we make x the subject of the formula, we will have x squared is equal to y squared minus 144. But we cannot completely solve for x since we don't know y. We have to first look for an approach to calculate the value of y. How do we go about that? We can also consider a second right angle triangle in this diagram on the screen. If you consider the right angle triangle ABC, where this angle A is a right angle, and applying Pythagoras theorem will give us 17 squared must be equal to y squared plus 8 squared, because in this system of right angle triangle, the hypotenuse is the line BC. And according to Pythagoras, the square of the hypotenuse, that is 17 squared, must be equal to the sum of the squares of the other two sides. That is, 8 squared plus y squared must be equal to 17 squared. So, if we make y squared the subject of the formula at this point, we will have y squared will be equal to 17 squared minus 8 squared. That can be simplified to give y squared equals to 17 squared is 289 and 8 squared is 64. By the time we find the difference, we will get y squared equals to 225. Now, going back to the expression we obtained from triangle ACM, x squared is equal to y squared minus 144. But now we have been able to obtain that y squared is equal to 225. So, going back to this expression, we have x squared is equal to, we replace y squared by 225. So, 225 minus 144. That gives us 81. So, x is equal to square root of 81, and that gives us x is equal to 9 centimeters.